Empirical formulae, video 2. So we've looked at simple empirical formulae calculations, and today we're going to look at ones that involve a little bit more working out, and you have to extract the information from the question. So let's look at the question. 1.24 grams of phosphorus reacted with oxygen, giving 2.84 grams of phosphorus oxide. Find the empirical formula. So how do we start with this, Miss McLaren?
Well, I think you picked up on a good point. You extract information, but what you also do is you read the question properly. So, for example, we have 1.24 grams of phosphorus and it reacts with oxygen.
So the two elements that we're looking for, because that's what we need for our empirical formula, are
phosphorus and oxygen.
Okay, fine.
So the elements, it would be phosphorus and oxygen.
Lovely. So we go back to the question, and I can see it's very easy. We need the mass of each element, we know that. So the mass of phosphorus is 1.24 grams. That's lovely.
So we put mass next. I've got to make sure the colours all coordinate.
Yeah, obviously.
So we have our mass.
We're very coordinated today.
Thank you, Dr. Bourne.
1.24 grams.
1.24 grams.
Now, what about the mass of oxygen? Because they've just given us the mass of phosphorus oxide.
So that's 2.84. So can I try this, Dr. Bourne?
Yes.
So if that's 2.84 of phosphorus oxide, and that's the amount of phosphorus, so if we take these two numbers away, that will give us a mass of oxygen.
Excellent. Have you got that lovely on one of your whiteboards?
Here we are.
Fantastic.
So the mass of oxygen is
1.60.
Excellent. I'm going to put that in.
Lovely.
So it's 1.60
So we've got the mass of the atoms of each element, and now we need the
number of moles.
Moles. Okay, great.
Excellent.
So moles equals mass over...
Now I remember that from a previous lesson. So number of moles is mass over AR.
So we need the ARs. Right. Have you got anything to help us with that?
I think, if you can recall from the periodic table, the AR of phosphorus is 31.
The bigger of the two numbers.
Yes.
Lovely. So it's 1.24 over 31, and that is, because we prepared this earlier, 0.04 moles.
Great.
Lovely.
Then we're going to
Second
continue with oxygen, Dr.
Okay, so that'll be 1.6, and I know you've got one of your handy little whiteboards here. 1.6 over 16.
Excellent.
1.6 over 16, and that is?
Now, I think I can do that calculation. That is 0.10.
Okay, so we've got the number of moles, 0.04, 0.1, but we need the mole ratio. So how do we work the mole ratio out?
Ratio. Let me actually think about this, Dr. Bourne.
I have to move out of the way.
Ratio, you can work out the ratio by looking at all the numbers, circle the smallest number, and divide each of the numbers by the smallest number. That will give you the ratio, Dr. Bourne.
Okay, so the ratio for phosphorus is always, it's going to be 0.04 or 0.04, so that's going to be 1. So one of them will always be 1, won't it?
Yes.
It's divided by itself. Lovely. And then 0.10 over 0.04, you can use a calculator, but the answer is 2.5.
Thank God you're here, Dr. Bourne.
So the ratio of our elements is 1 to 2.5. Now I can see a problem here. Can we go straight to the formula from that?
No, we can't, because then that means you would 2.5 oxygen atoms, and in formulas you always show whole numbers.
So if your answers come out as a whole number, there's no problem. But if your answer comes out as a half number, you've got to do something to make it to a whole number, but keep the ratio the same.
Correct.
So what would you do?
So what you have to do is you have to multiply it by a number that will give you the whole number.
Okay.
So if I look at these two numbers, I would say if you multiply that by 2, that will give you whole numbers.
Okay, fine. So if we multiply those by 2,
Then we have P, 2 times 1 gives you 2. And then for the oxygen, 2 times 2.5 gives you 5. So your empirical formula for phosphorus oxide is P2O5.
Perfect. So just to recap, we need the mass of the elements in order to work out the number of moles of each element, in order to work out the ratio, in order to work out the formula. Is that right, Miss McCarron?
That is correct.
Excellent.
Another successful
Another
lesson.
Success or success even. Job done.
Job done.
Okay.